And now for part 3 of this video, reviewing the practice test for the cumulative final exam, which is test number 3. Um, so for the first one, you're just asked to identify the sampling technique used. So um, going through the sampling techniques, this one's usually the first one's pretty easy to distinguish because every time you have every, you know, 23rd or 5th, anything that we describe like that, that's definitely a systematic sampling. Those are pretty easy to identify. Um, a group of people are classified according to the hairstyle, and then random samples of people from each group are taken. So the two things that people confuse mostly with these sampling techniques are cluster samples and stratified samples, and that's because both of them require putting people into groups. If I'm taking a sample from every single group, um, that would be stratified. That's why this one here is stratified. If I took only certain groups into my study or a certain number from selected groups, not all the groups, but just a select number of groups, then that would be more of a cluster. The first 35 students leaving the cafeteria are asked how much money they spent on class trips for the semester. So it's just basically like, hey, I'm just going to do a study now and just like see what's around me. It's convenience, which is, if you're setting up any kind of study, you really shouldn't use that kind of sampling. Dateline NBC conducts a study by recording the GPAs and various aptitude test scores of all students in 100 randomly chosen high schools across the nation. So, the groupings, although it's kind of students group themselves, because they go to certain high schools. So they just picked 100 high schools and took all the students from them. That's a cluster sampling. Because the groupings are, of course, the high schools. And, not all the high schools were tested. Only certain high schools were tested. So that's how you can tell the difference between the cluster and stratified, more importantly. For number 25, you were asked to calculate these various things with this. Some of them are quite easy, and some of them are a little bit more involved. Now, for the mean, not so much, but for the median, the mode, Q1 and Q3, you really should have the data in order. And the reason why you want to have that data in order is so you could tell which one's the smallest, largest, where the middle would be. So you could say like, if I want to know what the seventh highest term is, you could point that out. And if you have them in order like that, it's easier to figure out the mode because you can see like, the one that appears the most often. So the first thing you would need to do is spend time putting them in order. Um, so I'm going to do that with the aid of some video editing. It'll happen in a couple seconds, but so let me write them out. So those are all of these listed in order. There were a grand total of 18 in my sample here. And the first thing I would do to find the mean is I would add these together. So if I found the sum, which doesn't have to be in order for that to happen, um, and it's not an extremely difficult process, especially with a calculator, I would figure out that that's 2087. So the mean would of course be 2087 divided by 18, and that comes out to be $115.94. So that would be the average. We would report that as the average or the mean price for tents at local sporting goods stores. Now the median requires me to find the middle score. So there's 18. If I divide that in half, that's 9, and it comes out 9 exactly. Which means since there's no remainder, I need to find the average of the 9th and 10th term, which is why we needed to have these listed in order, because I'm just going to count off 1, 2, 3, 4, 5, 6, 7, 8, ninth. So this one here and this one here, this is the ninth term, this is the 10th. The median would be between these two. And so I would simply just take an average of those two values and get 95. So the median price is $95. The mode, I'm looking for the most frequent score. When I look at the mode, 58 appears 3 times, 82 appears 3 times. There's nothing else that appears more times than 3. And so this thing would actually have 2 modes. It's 58 and 82 would be the 2 modes for this. You can have more than one mode. You can have a whole bunch of different modes. As long as like one appears more frequently than some other piece of data. If I have like 10 pieces of data and I have 3 groups of 3 and one that just hangs around, and I would have 3 modes, so as far as Q1 and Q3 goes, these are like the halfway marks in these two, some parts that we split with the median before. So in here I have 9. So if I take 9 divided by 2, I get 4.5, which means I'm going to want the 5th term. So 1, 2, 3, 4, 5. This is Q1. And same thing here on the second group, 1, 2, 3, 4, 5. That's Q3. So those are pretty easy to do, again, once you have them in order. If you don't have them in order, that makes it very difficult. Now the standard deviation gets to be somewhat problematic because it's an involved calculation. And usually I set it up using tables and whatnot. So I would say, okay, well here's my values. Here's my frequency. Some of these appeared more than once, so this appears 3 times. 67 appears once. 82 appears 3 times. And I know what the mean is. And so if I figure out what x minus the mean is for each one of these, and then square it, and I could do this with the calculator. So I would do, for instance, I would have here 58 minus 115.94 squared, 67 minus 115.94 squared. And some calculators actually have standard deviation buttons on them as well. Which could help, and for this interest of time in this video, instead of me showing you all of these calculations, I'm just going to kind of, speed this up a little bit. So I would set all these up, and then I would basically do the frequency times that, especially for the ones that appear more than once, and I would get values over there. So I calculate them and I get the following values. And so I have all the frequencies times the score minus the mean squared. And so the standard deviation is just going to be the square root of the sum of those over n minus 1. So in this case here, if I took all those values there and add them up, I would have the square root of 62994.94-ish over 17, and that comes out to be approximately $60.87. So on average, score to from price to price between tents, they differ by about $60.87 on average. And so that's how you calculate the standard deviation. So it can be a little bit more involved, but sometimes organizing it into the table actually is helpful and helps you put it into your calculator a little bit more easily. So let's try a couple other problems here. This one here, starting salaries in thousands of dollars of social workers with a Bachelor of Science degree and no experience are shown for a random sample of 25 different social workers. So in A, they just wanted you to complete a frequency table, which isn't too hard because, I mean, they have them listed in relatively good order. I mean, if you go like, kind of down this way, kind of down this way and then over, then, down and then back up again, down. They're listed in order pretty much. So I can see that there's two 27s, there's two 28s, there's three 29s, there's 530s, 131, 132, 333s, and there are 8 34s. So here I have much more frequencies than I did in the previous one, but I would calculate some of these things in the same manner. So when I get to the mean, and which means this table is going to get a little bit obscured, I'm going to take each one of these and multiply it by their frequencies, and then add them together and then divide by 25 because that's how many there are. So so we have 25 samples here, and if you added them all together, the sum of the scores, or you took each one of these times their frequency and added them together, you would see that they total 781. So the mean is just going to be 781 over 25, which comes out to be 31.24. These next ones, having them in order and having the frequency table makes it kind of easy because the median should be halfway between these two. So if I take 25 and divide it by 2, I get 12.5, which means I should round up to the 13th. So if I count off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's the median. The mode, that's obviously 34. That's the one that appeared 8 times. Q1, now I'm looking for Q1, I'm looking in this group over here for its middle. There's 12 in that group, so if I take 12 divided by 2, I get 6 evenly. So the 6th and 7th one is what Q1 is going to be. So 1, 2, 3, 4, 5, 6, 7. Since they're the same number, and I've averaged them together, it's 29. For Q3, I'd be looking in this group of numbers over here, the higher end. And again, I'll be looking for the 6th and 7th term are there and finding their average. So 1, 2, 3, 4, 5, 6, 7. So they're both 34. So their average would be 34 as well. Standard deviation, I would just continue on with this table that we started over here with the number of social workers. So I would just go like a step further and say, okay, well, let this be X, let this be my frequency, and I'm going to let this be the frequency times X minus X bar, where X is the score, X bar is the mean, which again is 31.24, and I'm going to fill in this table. So I would have these, and then of course the standard deviation would be the square root of the sum of those over n minus 1. So I would sum those up, and if I sum those up, I get 150.56 approximately over 24. And if I take the square root of that, I get about 2.5047. So on average, and that's in thousands, so when I look at these values here and recognizing that all these values that were reported here are in thousands. So the mean salary is 31,240, the median is 31,000, the mode is 34,000, Q1's 29,000. Q3 is 34,000, and the standard deviation is about 2,504.7. So, you know, in the relative scheme of things, it's a pretty small standard deviation in comparison to the actual salaries. So that's how you do it in this instance. And also be aware of how to read these information from histograms and other plots as well. I mean, again, I can't go over every possible example, but be aware of how to read various graphs and things like that, which kind of gets us into the next one where I'm going to show. The last one. Here you have to find the mean, median, and standard deviation. So you have to remember that when you have a stem and leaf plot, which is what this is. I mean, so this data up here is actually saying, okay, I have data of 240, 250, 270, and 290. Then the list keeps going on and on. I don't know why this is having trouble writing on this part right here. And so, you know, and each one of these represents a data. Now, the cool thing about it is in order. It's a relatively large one, so again, you're not going to necessarily have 50 items to take the average of and do a standard deviation and so forth. You know, so it'll be much more tame. So, you know, as I did this and I went through it, you know, I used my calculator to help me, you know, obviously. So I know there's 50 items here. I know the sum, when I added them all together, was 25,570. So when I wanted to find the mean, over 50. I got 511.4. Now the median's not too hard because one of the nice things about having a stem and leaf plot is that the data is essentially listed in order. So, you know, if I'm looking for the median, I'm going to take that 50 divided by 2, I get 25. So I want the average of the 25th and 26th terms. So when I go back to this, and I count out the terms, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So I'm looking for the average between these two terms. That's, you know, the median would be between those two. And so 500 plus 510, the average of those two would be 505. And they're pretty close to the mean value too. So now as far as standard deviation goes, that would take up a considerable amount of space on this. But I would still kind of do the same thing. I mean, it might be easier to make it into frequencies, but I don't see a lot of repeating numbers all over the place. And so, you know, I would have to take like the 240 minus the 511.1.4, square that, take the 250 minus the 511.4, square that, and do that for all the data. Um, so, and I did do that. I'm just not going to show it all here. And it would take some considerable time to do it in this instance, but I mean, you should be able to do it. I mean, I would say like with 20 or less without, it might take a little bit of time, but 50 would be a little bit ridiculous for a test. That would take some considerable time. Um, so for the sake of argument, I did do the sum, and I counted each one individually. So the sum of the x minus x bar, where all the frequencies were 1 squared, I got 121,6402, which means that the standard deviation would be the square root of that number over 49, which is n minus 1, and that equaled approximately 157.56. And that brings us to the end of this third video and finish the review of the practice test. Again, keep in mind that, make sure if certain graphs were shown here, but there's other graphs you have to be aware of, make sure you're aware of them too. If there was rules, dealing with angle measurements, make sure you know all the rules for different angle measurements under different circumstances. Make sure you know how to do your logic tables, make sure you know how to set up Venn diagrams, make sure you know how to find various counts, do various probabilities, even ones that may not have been focused on in here. So review some of the other materials that you have as well as you go along with this. But if you have gone through this fairly well and did fairly well in getting the solutions correct to these, you're pretty well set for the third and final test. So if you have any additional questions, please make sure to reach out to me. Until next time, have a good day.